So thank you again for joining us. My name is Bryce. My pronouns are he, him, and I'll be guiding everyone through our session this evening. To begin, I'd like to say a few important words. As a treaty person, I'm grateful to be able to live, work, and play on this land. Western's campus is located on the traditional lands of the Anishinaabeg, Haudenosaunee, Lenape, and Chinookan nations. These lands are connected to the London Township and Sombra Treaties of 1796 and the Dish with One Spoon Covenant Wampum. Thank you very much for being here tonight. Today, I'm joined by my co-host Ryan, a number of staff, faculty, and current students from the Faculty of Science, and of course, all of you. Welcome. Let's go through a few housekeeping items before we get going. First, this session is being recorded. It will be available on our website in about a week or so. You'll be able to find it on the same page you went to for registration, welcome.uwo.ca/presentations. Next, live closed captioning is enabled for this webinar. If you'd like to turn it on, you'll find the live transcript button on the bottom bar. Then you can choose show subtitle or view full transcript. Just remember though, this is live closed captioning, so we can't guarantee the accuracy. Next, your video and audio will remain off today, but that doesn't mean we won't be interacting together. We'll have polls throughout the presentation, and we also want to answer all of your questions. You can submit a question by using the Q&A box. You'll find this at the bottom of your screen. You can enter questions now or anytime throughout the presentation. Someone from Western will type an answer to you, and we'll answer a few questions live at the end of the presentation. One tip about questions: be as specific as possible to get the best answer. So let's get started with a poll right now. If I can have my colleague Ryan launch that poll, we'd love to know where you're joining us from this evening. Are you joining us from right here in London, Ontario, elsewhere in Ontario, elsewhere in Canada, or maybe elsewhere in the world? And it looks like we have some folks joining us from all over. Wonderful. We'd also like to know, who are you joining us with this evening? Maybe a parent or guardian, a friend, sibling, or are you joining solo this evening? Wonderful. Well, welcome everyone. We're so glad you're here, and thank you again for taking some time out of your evening to learn a little bit more about science at Western. Let's get to our schedule for the evening. First off, we're going to have a welcome from Associate Professor and Assistant Dean Dennis Maxwell. Then John DeHuse and Andrea Legato will walk you through the Faculty of Science at Western, things like what courses you could take and the experiences you can have. After that, we'll have a mini lecture with Professor Patricia Corcoran on addressing plastic pollution through a scientific lens. After that, we'll get to know some of our current Western Science students in a student panel. They'll share some of their own experiences here at Western. And finally, we'll all join together at the end to answer some questions live. We hope you'll be able to join us for the entire event, but if you can't, no worries. As I mentioned earlier, there will be a recording available on our website. And don't forget to sign up for our other events. We have lots of other events coming up this spring. If you haven't attended a Next Steps presentation, we highly recommend you do so. It's helpful for everyone to understand what to do before coming to Western. We also have a special presentation about residence if you're thinking about living in residence or you just want some more info. And last but certainly not least, a presentation from Student Experience. You can sign up on our website, the same place you signed up for this presentation, welcome.uwo.ca/presentations. Without further ado, let's get started. I will now invite Associate Professor and Assistant Dean Dennis Maxwell to say a few words to welcome you. Take it away, Dennis.
Thanks, Bryce. It's so great that everybody could join us this evening. So I'm going to give a pretty broad overview of Western and what the programs in Western Science have to offer. And then I'm going to hand it over to my colleagues, Andrea and John, who are going to drill down and talk much more about some unique aspects about how degrees at Western are constructed and the whole modular system that perhaps you have heard something about. So here's a slide of some current undergrads at Western Science who have come here to really explore their passions and curiosities for science. I really love this slide. You know, overall at Western, we see undergraduate education really as a continuum, which gives all students time in first year really to explore what path they want to head down. And I think that that's really important. So time in first year to really discover what they want to do and then engage with them over subsequent years and really getting every student to thrive as an undergrad, thrive when they graduate, and continue to thrive as they enter the workforce and contribute to society. So that's kind of the trajectory we see at Western. And it all starts with giving students time to discover their passions in first year. Now, if you come to Western Science, you'll be part of this remarkable Western science community where we have 9 departments and programs, and we have professors and graduate students and undergrads all working together, teaching and learning and doing research. And you know, if we think how the last 2 years have gone with the pandemic, I think we did a good job of pivoting to online education, and we did a good job of teaching chemistry online. But I think what we missed was the sense of community, the community within the Faculty of Science, but overall, something else that Western is known internationally for. It's outside of the academic sphere. It's the overall student experience, what contributes to making a university education really special and unique. You know, the ability to do sports at the varsity level, intramural, join student clubs, amazing arts and culture, just campus diversity and opportunities that we're missing, and we know will be back in place, ready to go in September. And you know, yes, these things fall outside of the academic sphere, but we know that the research is very clear that when a student has a sense of well-being outside of the classroom, it has a profound impact on how well they do academically. So it's really important, and I think we've learned a lot over the last 2 years, that the university is so much more than just academics. And if you come in September, you will be a part of the remarkable Western student experience that we have here. So yeah, it's tough, you know, if you think your grade 12 physics exams and chemistry exams are hard, how do you pick? You know, Ontario has 21 remarkable institutions. Now, some of these are very specific, like OCAD and things like that. If we just drill down, Western is considered a large research intensive institution. So similar to McMaster and University of Guelph, in Queens, you know, roughly about 27,000 undergrads, not nearly as big as U of T, which has upwards of 70,000. But research intensive means that yes, that Western does big internationally recognized science. And this picture from campus, I think, really shows this off well. On the left here is the Biotron. This is an internationally recognized research facility used to study climate change, because you can do experiments in the Biotron that you couldn't do in the small footprint of a normal research lab. You can change CO2 and temperature and light and things. You can mimic climate change the way perhaps it would happen over the next 50 or 100 years. And on the right is a newer building, Western's Interdisciplinary Research Building. And this is the home of the Brain and Mind Institute. So when it comes to neuroscience, brain biology, everything from psychology to brain anatomy, Western is absolutely recognized internationally for this. And the Brain and Mind Institute was set up after we were able to recruit Adrian Owen to Western. He was at Cambridge University in the UK, and we were able to recruit him here. So the Brain and Mind Institute, the Biotron, just two facets of the internationally recognized research that we have at Western. So of course, all this talk about Western and your undergrads, you know, like I'm just an undergrad, but I think it's important to know that science has well over 150 research programs run by various professors, and every one of them has at least one or two undergraduates in the lab doing amazing experiments alongside graduate students and postdocs. So there's lots of opportunities for undergrads to get involved in research. Perhaps it starts by just being a laboratory volunteer. You could get a summer research assistantship where you'd actually get paid to work in a Western lab for 4 months. And as well, many of the concentrations, the modules that our students will go into, they usually lead to a capstone experience in 4th year, where you'll actually do a course, a thesis project, which is worth at least 1 to 1.5 course credits in a research lab. You'll actually write a thesis project. So it's not like undergrads don't belong in research labs. Undergraduates and the research they do are a major facet of the research mission of Western. And it's a remarkable interaction of how undergrads interact with other professional researchers. And of course, all this talk about research at Western, I think it's important that we note that we don't think that teaching takes a backseat. In fact, here are some pictures of some of the award-winning instructors we have in the Faculty of Science. So teaching and learning, getting undergrads to understand science as it exists today is something that we are very proud of. And we put a lot of resources into the teaching mission. And unlike when I was an undergrad, you would sit passively in a lecture hall taking notes. Instructors today build their lectures and their teaching opportunities around what we call high impact practices. So lots of collaboration. We know that teamwork and group work is important in the workplace. So we have to build that kind of those traits, those skills in our undergrad. So collaborative assignments, writing intensive courses are important. Of course, in science, lots of lab courses. We already touched on thesis projects. And I think one that's really grown in the last 5 to 10 years is experiential learning, getting undergraduates outside the lecture hall to experience science firsthand. And so lots of field courses, especially in biology and earth science, taking students in the field to study and to actually do coursework. And arguably, the most profound high impact practice we have is the internship. And so the internship, you don't have to do an internship, so it's not quite like a co-op, but these are paid career placements that students can go on. They're about 8 to 16 months. So what's awesome is you get paid. You get paid and you get to experience a real job for a company or a government organization. And yeah, 8 to 16 months, and internship is usually at the end of year 3. So you've completed 3 years of undergrad, you'll go away to your internship and then come back and complete your undergraduate degree by completing your 4th year. And it's remarkable, you get academic credit for internship. And I think about half of our internship placements are actually offered a full-time job. When they leave the internship, they're offered full-time job if they come back after the 4th year. So it's remarkable. Students who go on internship really think it's a major and important milestone within their overall undergraduate career here. So I just want to talk about 2 specific programs that we're excited about here in Western Science. And the first one is data science. I think we can all appreciate that collecting data is easy. we can collect vast amounts of it, huge amounts of it, but finding the underlying meaning of that information. So that's a lot harder. So if you think about genome sequencing the A, G, C's, and T's that make up the DNA of an organism, that's pretty cheap. In fact, you can get your own nuclear genome sequence for about $5,000 today. The A, G, C's, and T's, that's easy. Figuring out what that sequence means, seeing if you have a predisposition for heart disease or Alzheimer's or specific cancer, that's data science. That's taking the information, that's taking just the data and gleaning more information. So data science, remarkable, a very popular program here. It's a little statistics, a little computer science, so it's offered jointly between the departments of computer science and statistics, statistical and actuarial sciences. So the other one is our integrated science program. So this is limited to about 60 students a year. If you're still interested and you have an offer for Western, you can still apply to integrated science. This is aimed at students who just love science. They're passionate about science. Maybe they don't know whether they want to go into chemistry or biology. Integrated science really immerses students starting in first year in a wide breadth of sciences. You'll take more science disciplines than a normal student. For example, you'll do a little earth science, a little computer science. You will do some astronomy. And the whole philosophy around integrated science is to get a handle on these big questions that humanity now faces. Things like climate change, developing alternative energies. These aren't biology problems or chemistry problems or physics. They require a team approach, expertise from a broad range of disciplines to come together. And so that's the idea behind integrated science. Give students a breadth of understanding as well as concentrating. Every student in WISC needs to concentrate in year 2, but overall, for example, you may concentrate in biology, but you will have a greater breadth of understanding of scientific disciplines compared to most students. So we're really excited about integrated science. And again, if you're interested in this, there's still time to apply. Okay, so now I'm going to pass the baton over to Andrea John, who are going to drill down more deeply into how degrees at Western are structured.
Thanks, Dennis. So, hi, everybody, and welcome to this evening. It's a pleasure to talk to you all. So what I'm going to talk about right now is about the career path. So Dennis has done a great job sort of elaborating and pontificating about what the merit of what's unique to Western science, the esteemed professors we have, the unique programs we offer. What also is unique to the university is we have a modular system of degrees. And what that basically means is that you can customize the degree in a manner in which you can do areas of discipline that may and combine 2 areas of interest that are very opposite or very similar to each other. So we offer over 360 courses approximately that can be used in over approximately 95 modules. So the combinations are endless. And you could be that student who combines a biology degree with a philosophy degree or a chemistry degree with a art history degree. That's all doable. So if you're coming to the science and you're like, John, I have 2 passions. I want to do X and I want to do Y. Am I able to do that? If we offer those areas of study, absolutely. You may even want to just do a minor in the area of study. And that may be germinated with the elective you take in first year, because maybe by chance you take a French course, you take a history course, and suddenly it sort of opens up a whole new world that you weren't thinking that existed. In addition to those combinations and modular degrees, we also have what we call dual and concurrent degrees. So we have a unique program with Ivy where you can do a dual degree, which is the honors HBA in tandem with the honors BSc degree. It takes you 5 years to do. I know that some of you here tonight probably may have AEO status, so that's an area that may be of interest to you. Any honor specialization in our faculties that the faculty that we offer can be done with an IVHBA degree. Keep in mind that it does take an additional year. In addition to that, we also have concurrent degrees. A concurrent degree is when you're doing a professional degree in tandem with an undergrad degree. So that can be a music degree in tandem with an undergrad degree in computer science or mathematics. It also could be an engineering degree, which is both music and engineering are professional degrees in tandem with physics or computer science. So in essence, at the end of your 4 or 5 years, you would walk out with 2 degrees in hand. So what is a Western degree and how is it built? So a 4-year degree at the university is 20 credits in total. So you're every year you're accumulating 5 new credits to that tally. So next year, coming into September, you will be planning to take 5 courses. And those 5 courses will be 5 per term. And so some of those courses may be a full year, so they'll run from September all the way to April, but many of your science courses are actually 1 semester, and then the partner to that second will be in second semester. One thing to just address real quick is the suffix endings are quite important. And you'll understand that when you get down to course enrollment. But just as an example, when you see Calculus 1000A and Calculus 1000B, they are the exact same course. So no need to enroll in both. One is sufficient, and then you want to buddy that up with the second half of calculus or an applied math or a linear algebra course. At the conclusion of first year, you'll have completed the admission requirements for an area of discipline of study or a module, and those remaining 3 years that you have the complete degree will be the composition of those 15 credits. So first year is a launching point. It's basically, where do you go next? So first year, I saw some comments here from students already about you're in computer science or you're in biology. Well, actually, you'll be in computer science or in biology in your second year. Now, first year is about focusing on the admission requirements of that said program. So some of you coming in September will want to do computer science. Others will want to do biology, chemistry, math. And so what's important is that you look at and familiarize yourself with the admission requirements. And then the next step is, what degree do I wish to pursue? Because some of the admission requirements are different. So there's honor specializations, there's a double major, which as it says is 2 majors, and then there's a single major, a specialization, or a minor. And at the far right-hand side of this slide, you'll see that the 2 at the very top fall under the honors degree. So, and the other 3 fall under a bachelor, a 4-year degree. So at the university, we offer 2 types of degrees, honors and non-honors. I wouldn't get too caught up today what you should do. That will sort of work its way out as you progress through your first year. But basically the difference is an honors degree requires higher academic requirements, grades of 60 with an average of 70% in the modular courses. And the unique feature to that is in 4th year, many of the in your honor specialization, you'll do a mini master's, as I like to call it, a thesis course, which is a great introduction if you have goals and aspirations beyond to do postgraduate work, whether it's master's or PhD work. So again, we have first year, we have those 5 first-year courses. If you're doing the honor specialization, the remaining 15 credits that you have to do over years 2, 3, and 4, a lot of them are between 9 and 11. So we use 10.5. So you've got 10.5 that are occupied, monopolized, shall we say, from those remaining 15 credits. So you've got 5 first year for the admission requirements, 10 from the module itself. That tallies to 15.5. The remaining 4.5 credits are electives. So that where you get 20 credits. Those 4.5 electives can be in anything and everything you want it to be. So we offer courses on Harry Potter. We also offer courses on the Tragically Hip. We offer courses on languages. So it's a very unique, we offer it on zombie movies. So you can appreciate that it's very unique, and you could be taking an elective that all your peers are not even taking. And that's the whole purpose of an elective, is to explore and discover things about yourself that you never knew existed before. So the other unique thing about modules is the flexibility. So when you come into first year and you're like, John, I'm doing computer science, and that's fine, and that's fantastic. But the beauty of it is the flexibility and maneuverability of said program. So a lot of the programs that fall under computer science have the same admission requirements. So you may be thinking to yourself, I'm going to do computer science in second year. And then lo and behold, you take an elective in an information systems course. There's 1033 and 1032. And suddenly your mind is blown, kind of like, wow, I never knew this existed. So you transition then to that area of study. But then in second year, you take another comp sci course that really opens your mind up even more. And you're like, you do data science 2000, and suddenly you're like, you know what? I like to do data science instead. All easily maneuverability. So again, when you come on your first day of class, you're not now committed to that degree for the next 4 years. You have the possibility and the luxury of moving from one field to another field. Now, eventually, and the beauty of it is you can complete that in 4 years. Now, obviously, as you get closer on and you move along and it's now third year and you decide to do a turn, that may add to an extra semester or an extra year to your studies. But the nice thing is that in many ways, you've got about 2 years to sort of work it out, what area of studies you want to do. For instance, biology and genetics have the exact same requirements in second year. So you might want to do biology second year, and suddenly you take our genetics course 2581. And again, the world just looks so differently now from that course, and that's the area you want to go. So what's first year going to look like? Well, you have to do your modular admission requirements. And in some cases, that can be as little as 2.0 of those 5 first year courses you have to do. And it can be in some cases anywhere as much as 3.5 to 4.0 courses. In addition to that, you're going to take a non-science course. So one of our degree requirements in first year is that you must take a 1.0 course outside of the area of science. And that will be either in the area of social sciences, category A, or the arts and humanities, which is a category B. Some examples of category A social science courses: psychology, history, political science. Other examples of category B, which is arts and humanities, would be a philosophy, a classic studies course, a language course, French, Spanish, and so on. And then whatever's remaining, you can take other electives and options. So for instance, our computer science students, there's 2 required admission courses. Then you have to take 1 non-science course. So let's just say you take economics, and then that leaves you with 2.0 electives. So you can add on 2 comp sci electives, and you can add on an astronomy course, and there's your year. Perfect. So it gives you the great flexibility. I'm going to transition over to my colleague, Andrea, who is going to discuss to you about the admission requirements of said programs. It's been really nice talking. I wish you a great rest of the day. Have a great
Hi, everyone. I'm Andrea. I am another one of the academic counselors here in the Faculty of Science at Western. Excited to chat with all of you tonight. John and Dennis have done a great job of talking a little bit about the faculty, kind of broadly what you can expect, as well as how our modular system works. And I'm going to talk a little bit more about what your first year might look like, as well as some of the resources and supports that are available at Western to help you succeed. So John's already talked about how in first year, you're coming into a common first year. So everybody's coming in without yet being in a module. And the courses that you take in your first year are going to act as prerequisites to gain you admission into whatever module or combination of modules that you're hoping to enter in your second year. So on the slide that you can see in front of you right now, we've provided just a couple examples just to kind of illustrate what we mean. So if you are considering doing an honor specialization in biology, for example, these would be the courses that you'd be required to take. So 1.0 biology, 1.0 chemistry, 1.0 math. So that means you're going to have 1 biology, 1 chemistry, 1 math in each of the fall and winter terms, as well as a half physics credit. The rest of your year, so the remaining 1.5 credits, will be rounded out with electives. And those could be, like John said, at least 1.0 will be outside of the Faculty of Science, but they can be in anything that interests you or that you feel drawn to. They could also act as, if you find a discipline that you're really interested in, they could act as prerequisites to do a minor in a different faculty. If you take first year psychology and you love it, you might want to add a minor onto your honors special biology. And then in the next column, you can see the required courses for an honors specialization in computer science. So a half computer science in each of first term and second term, fall and winter, 1.0 math credits. Again, we'd like to see those balanced across 2 terms. And then the other 3.0 are up to you. So there's a lot of flexibility here as well. And what I always like to emphasize with first year students, and what John has already done a great job of emphasizing, is that you're not locked in at this point. You have the flexibility to change your mind, or to add something new on, or to just explore a whole bunch of different disciplines with the electives that are available to you, both in first year and beyond. And then, okay. We'll move on to, no, I was just going to say there's a little note at the bottom just talking about how you need to have an average of at least 70% in your 3.0 principal courses to progress. Like John said, this isn't something you need to worry a ton about at this point. That's one of the admission requirements for an honors degree. But if you have questions about how you're doing academically, how you're progressing, that's where academic counseling can come in to assist. So we are one of the resources on campus that can help you thrive. We are here to help you navigate kind of the academic side of things, so your academic choices. So that's things like course selection, module selection. What's going to happen is that in March of your first year, we're going to go through a time of year called intent to register, where you're going to let us know what major or minor or honor specialization you want to enter in your second year. If you have questions about what options are available to you, we're the people who can help you with that. We can also help to make sure that you're meeting your progression and graduation requirements, that you have everything you need to graduate at the end of your 4 years. And you can connect with our office in person, and we're also available virtually by Zoom, as well as through live chat on our website. And then kind of on the other side of the house, the non-academic side of the house, we have all of the supports offered through our student experience side. So those are the people who can help you with your health, your wellness, your well-being, if you need to see a doctor, a mental health practitioner. If you're looking to get some help identifying career options, perfecting your resume, practicing for interviews. If you require accommodations, academic accommodations, they can help you with that. And if you need additional learning support, so things like help with test taking, help with note taking, that sort of academic support they can provide you with. And the other thing that they're going to help you with, it's really important for you at this point in your journey, is that they offer our summer academic orientation program. So once you've accepted your offer to Western, once we get into June, you're going to be able to connect with the SAO office, and don't worry, you don't have to commit all this to memory. They will reach out to you. And that's where you can attend live or recorded sessions about course selection, as well as have a one-on-one appointment about your course selection. So if you're thinking, oh my gosh, I'm not going to commit everything that you said tonight to memory, what am I going to do? There are people who can help you with that. Okay, so if you have questions about modules, if you want to keep doors open to a few different modules, attend an SAO appointment, let them know what your interests are, and they'll be there to help select the right courses and to navigate that. Western's a big place. We have amazing supports available on campus, but because it's big, it can be a little tricky to navigate. So if you ever don't know where to go, please reach out to academic counseling. We're pretty connected. And even if we're not the right place, we can usually connect you with the correct people. So best of luck with your decision-making. We're really excited to have you here tonight, and we hope to see you again in September.
Wonderful. Thank you very, very much, Andrea, John, and Dennis, for that wonderful overview of the Faculty of Science here at Western. I think the resounding theme there was the flexibility in that common first year and then building those modules, building your degree, making it work for you, and discovering your passions. You never know, you might get to Western, find out something that you weren't really thinking about in high school, but it becomes a passion of yours, and adding that in as a minor or maybe a double major. So thank you so much for sharing all of that with us this evening. Now that you've had a chance to learn a little bit more about the Faculty of Science, we wanted you to have an opportunity to sit in on a mini lecture. So this is going to be from Professor Patricia Corcoran, and it's going to be focusing on plastic pollution and looking at that through a scientific lens. So welcome, Patricia.
Hello, I'm Patricia Corcoran. I am a sedimentary petrologist in the Department of Earth Sciences at the University of Western Ontario. Are you aware that roughly 370 million tons of plastic was produced in 2019 alone? It's estimated that of all the plastic that's ever been produced, 60% of it remains in landfills or in the natural environment. Today, I'm going to explain where that plastic is located and what we're doing at Western Science to effect change with respect to plastic pollution. Now, all of you have seen plastic debris in shorelines or along roadsides or in parks. Most of that plastic debris is what we call large plastic debris or macroplastics. This is dangerous to the environment because organisms can become tangled up in it. But what you may not be aware of are the small plastic items that we find buried in the water column or in sediment. These smaller pieces of plastic debris are known as microplastics. Microplastics are plastic particles that are less than 5 millimeters in their longest diameter. Microplastics are formed to be small, for example, microbeads in personal care products, or microplastics form from breakdown of larger plastic items. Microplastics can be a significant risk to our ecosystems because even the smallest organisms on the food chain can ingest them. Things like worms, plankton, and mussels. Now, any kind of organism that is a benthic organism or who lives near the bottom of the water column can forage for food in the sediment and ingest some of those microplastic particles. Scientific studies have shown that the ingestion of microplastics can cause feeding, mobility, and reproductive changes in those organisms. And if the smallest ones are affected by microplastics, then the consumers, such as larger animals or humans, will also be impacted. My research group in the Department of Earth Sciences studies the distribution, degradation, and accumulation of plastic debris in bottom sediment of lakes, oceans, and rivers, in the Great Lakes watershed, as well as in the Canadian Arctic. We study how microplastics in sediment can affect different types of organisms. We can inform policy to help people understand exactly what the dangers are of plastics pollution. In a study of one river, we determined that between 600 and 2,400 particles of microplastic were present in 1 kilogram of dry weight sediment. That's equivalent to 2,400 particles of microplastic in half a bag of sugar that you buy at the grocery store. Even larger microplastics like pellets are dangerous to the environment because they absorb persistent organic pollutants. Those pollutants can then leach out into the water or into any organisms that are eating them. Plastic pellets, these small circular structures, are the raw feedstock to create larger plastic items. So the pellets are formed in a factory and then are then shipped by rail car or truck to another factory where they're melted down and molded into the plastic items that you use every day. Unfortunately, these plastic pellets often get spilled, either within the factories and make their way down into the drains and out into natural water courses, or they're spilled during transport or offloading. In a study in 2018 that we conducted, we sampled 66 beaches across the Great Lakes. And what we found was that the greatest number of pellets are associated with proximity to Canadian plastic industries, as well as anywhere the spill has once occurred. So for example, Baxter Beach in Sarnia is an area where we find a high abundance of pellets. On that particular beach, we found 726 pellets per square meter. The good news is that our data has helped inform the joint writing of a policy document with the not-for-profit organization Pollution Probe, the University of Western Ontario, the University of Toronto, and the Plastics Division of the Chemistry Industry Association of Canada. Another project that we're involved with is the project called the Great Canadian Lakes Cleanup. And basically what that involves is sea bins are placed at marinas throughout the Great Lakes. The contents of those sea bins are then sent to our lab and to labs at other institutions like the University of Toronto. We look through that debris, we find plastic items, we measure them, characterize them for their types and their colors. And we take that data and we join it together with data from other labs. And from that, we're able to actually see that there are different kinds of trends with respect to plastic pollution in the Great Lakes. Closer to home, we work with the City of London, Ontario, in characterizing plastics that get trapped in what are called litotraps. Litotraps are installed in stormwater drains in some locations in the City of London. And what we do is we look at the trap contents in order to determine what types are located there. This can give stakeholders an indication of where the plastics are coming from, so it enables us to determine a source for the plastic debris. We all have a role to play in saving our planet. What you can do, or where you come in, is you could actually reduce the number of single-use plastic items that you use every day. Things like straws, plastic utensils, or styrofoam containers. None of these articles are recyclable and end up in the environment or in landfills. Alternatively, if you're really interested in the science of plastic pollution, you can always come to Western and join our interdisciplinary research group. Thank you.
Thank you very much, Patricia, for that mini lecture. And that just goes to show some of the research opportunities available to you here at Western. So now you've had a chance to sit in on a little mini lecture. Before we get to our student panel, we'd like to turn the tables back to you and launch a couple more polls. So if I can get my colleague Ryan to launch that next one, we're wondering, what are you most looking forward to when you start at Western? Is it your program and choosing courses, meeting new people, maybe moving away from home if you're not from London, trying something new? And we've got a lot of folks saying all of the above. Wonderful. So lots to be excited about. Next question, a little bit of a trivia question. We'd like to know if you can figure out who went to Western. So we have Marvel superhero Simu Liu, Canada's first female astronaut, Roberta Bondar, TV star and blogger Lainey Liu, and DJ duo Loud Luxury. All right, responses are coming in. I probably should have added an all of the above here, full disclosure, because all of those celebrities are proud Western alumni. All right, two more to go. Our penultimate question here, have you decided if you will be joining us here at Western this September? Yes, I can't wait, some of you are saying. Others are thinking about it, not official yet. And we've got some folks that are still waiting or making their decision. Not to worry, there is still time, and we hope that we'll be able to see you on campus sometime in September. Okay, last question. We would like to know, what was your favorite grade 12 science course? Was it chemistry, biology, computer science, physics, calculus? Ooh, biology is taking a big lead here. All right, we're pretty well balanced. Shout out to all those who chose calculus. I was a former math teacher myself, so happy to see some calculus fans in attendance this evening. Wonderful. Well, thank you so much for participating. We love hearing from you. And now is your chance to hear directly from some current Western science students. So I would like to now welcome Lama, Megan, Lydia, and Shaunik to join me on screen for a little student panel. Hello, welcome back. Thank you so much for carving some time out of your evening to be here with us. So before I start throwing questions your way, I'd love if we can just go around and introduce yourself to the attendees. Let them know what you're studying, what year you're in, as well as where you're from. So I guess in order on my screen here, we'll go Lama, Megan, Lydia, and Shaunik to finish us off.
Thanks for having me. So I'm Lama. I'm studying computer science. I'm doing an honors specialization with a minor in game development. I am from London and I just completed my 4th year. I'll be staying for another semester to do a couple more courses. So yeah.
Hi everyone, I'm Lydia. I just finished my 3rd year and I'm in honors spec biochem and chem.
Hi everyone, my name is Megan. I'm currently actually on internship between my 3rd and 4th years, and then I'm going back to finish my degree in integrated science with an honor specialization in physics. I'm originally from Victoria, BC, so way out west.
Hi everyone, my name is Shaunik. I just finished my 4th year honor specialization in synthetic biology, and I'll be continuing to do a master's of science in biochemistry, and I'm joining you from Etobicoke.
Wonderful, thank you. So we've got folks in all different areas of science, all different areas of Ontario and the country. So thank you all for being here this evening. We're all excited to hear about your experience at Western. So I guess I'll start it off with a popular question. What was your favorite course that you've taken so far at Western? Did one stand out to you, or maybe it was a professor, the way they taught it? But if you can share some insight on your favorite course here at Western.
So I personally had a lot of favorites. I can't really come down to pick with just one course, but I did have a very recent course called game design, and it is taught by one of my favorite professors, Professor Mike Kachabaugh. And it sounds fun because it really is fun. You look at how games are developed, what are the best strategies of catering to the most players and learning what's best for a game. And we get to build our own games as well. You get to build it whether individually, and you can choose if you want to continue to build it in a group or continue independently. So it was super fun. I had many other courses that I really loved, taught by amazing professors. It's mostly the professor that really makes the course for me, such as Professors Mahmoud El-Saka and Professor Roberto Salasoba. They're like some of my favorites. So yeah.
Thank you so much, Lama. I will open up the floor. I see Lydia's unmuted there. If Lydia, you'd like to add something.
Yeah, my 2 favorite courses were both in inorganic chemistry. So the 2nd and 3rd year courses taught by Dr. Ragonia and Dr. Gilroy. So if you're planning to go into chem, I highly recommend.
Wonderful, thank you.
I think one of my favorite courses, again, as the others have said, there have been a few, but I really liked a 3rd year course that I took. It was called Science in the Community, and it's a community engaged learning course. Oh my gosh, I'm so sorry, a postcard just fell off my wall. So in this course, they pair you up with an organization in the London community, and you help this organization with a project they're currently working on. So you really get to take your learning out of the classroom. You get to apply what you've learned in different ways and kind of see how your degree is applicable after you finish. So that was a really great experience, and I really enjoyed working with the organization that I was paired with.
Thank you, Megan. So yeah, it sounds like you're doing an internship now, and then you also had that community-based learning opportunity. So some chances to get outside the classroom and explore science in the community. So thank you very much. And over to Shaunik.
Yeah, so just to reiterate, I think that the professor really makes the course for you. One of the best courses that I had in my undergrad was Biochemistry 3381. It was taught by 2 professors, Dr. Chinoob and Dr. Choi. I don't know if any other panelists have taken that course, but one of the main reasons I enjoyed it so much is because it allowed us to have small teams and basically conduct our own research project and prepare our own final report to the level of something that you might see in scientific journals. So it was a lot of independent work with some supervision. which I feel like really helps you develop as a scientific researcher. So that was one of my favorite courses.
Thank you very much, Shaunik. And I'm sure that was helpful as you're heading into your master's program now, getting that experience. And I like that you touched on the size of your projects in your class, because I think sometimes students, incoming students might think every university class is this huge lecture hall. And while that might be the case for some first year courses, you're going to have labs and tutorials taught in smaller groups with TAs. And as you get further on in your studies, you'll have courses that are much smaller as well. So thank you all for sharing that. Next question. You've touched on this a little bit already, but I'd like to know what are some of the ways that you've gotten involved on campus, either through clubs, sports, jobs, internships, extracurricular activities. If you can share a little bit about that with our attendees this evening.
My way of connecting with the rest of the students was through clubs. I've met a lot of biology students, genetics students, despite me being in computer science, and I'm really great friends with them today. I'm constantly like talking to them and meeting up with them and just sharing interests. There's a lot of clubs at Western. They can like cater to many different interests. So I would suggest looking into those if you'd like to meet people in other disciplines.
Yeah, so in terms of clubs, there are definitely there's a lot of variety. There's social clubs, more academic based clubs. And so you'll definitely be able to find people that share similar interests with you. Personally, I've also been able to try a bit of research. So I'm currently doing research throughout the summer in chemistry and in physical chemistry.
So as the others have mentioned, there's a lot of clubs and opportunities that way. But one of the things that I did was I was a resident SOF in my second year and also an off-campus SOF in my third year. And so being part of the SOFing program at Western allowed me to get to know a lot of people in a ton of different programs and with super diverse interests. So that was a really fantastic way to get to know people on campus better. And then as Lydia mentioned, I also participated in meteor-based research over the summer. And then my internship this year is with a professor who also owns a company outside of Western called MRIDT. So now I'm on internship and the lab is on campus. So sometimes I'm still on campus, and then a variety of other clubs and student organizations as well.
Yeah, so as other people have mentioned, I was also involved in research on campus in the undergraduate with a professor from the Department of Biology. And some other extracurriculars that I enjoyed was working with the university's iGEM team. And iGEM is basically a competition for synthetic biology and biochemistry, where you tackle an issue and present a project in this big international conference. But one thing I'll just say about extracurriculars is I really think everyone should strongly consider starting early and exploring the different options Western has to follow, because often some of your best friends and closest friends throughout undergrad will be found through your extracurriculars, because you'll find people with similar interests, and like-minded people tend to click together very well.
Excellent advice there, Shaunik. Thank you. And it sounds like you've all been very, very busy, but doing lots of exciting things on campus. So thank you very much for sharing that information. Next one, two-parter, but it's a quick one. What is your favorite spot to study on campus? And where is your favorite spot to eat? So maybe we'll reverse the order this time. Shaunik, you can lead us off, and then Megan, Lydia, and Lama.
Sure. I think my answer might be a little bit obvious. It's not that there are a couple hidden study spots, but I'll definitely recommend Taylor Library on campus. And if you want a slightly hidden away, quiet study area on the library, you can go to the stacks at Taylor, which are slightly isolated and slightly hidden away. There's ports to charge and tables and chairs to sit on. So if you really need to get work or need to study for exams, that's a really good spot. And for a good place to eat, honestly, my classes were often back to back. So for me, the best place to eat was the one with the shortest line. And for lunch, really, they can be some pretty big lines. So try to leave some space in your schedule for lunch. I unfortunately did not and had to suffer a little bit, but that's my bit of advice.
I really liked studying at the Chuckma Engineering Building. There's these rows of desks that face big windows, and they're quite large, and they have outlets and all that kind of stuff. So I really like to go there to study, especially now that they're adding more coffee shops and stuff to the engineering side of campus. In terms of eating, I am a big fan of the Spoke. Got to get a bagel every now and then. It's just a classic on campus. And then also, I think the Grad Club has some pretty good options too.
Yeah, I have to agree with Megan on Spoke. That's definitely a fan favorite. And my answer is actually quite basic. I enjoy studying at Weldon here on campus. So yeah.
My friend group also finds Weldon like the best place to study at, because they do have different levels of like they allow conversation in some floors, and they allow like, or they don't allow any in other floors. Like it has to be pitch like quiet. So if you have like different types of moods, you can go to whatever zone you'd like to go to. I personally like to eat while the weather is still good. There's like right outside and outside, there are these stones in this semicircle. I really enjoy sitting there just to kind of chill, hang out with friends and eat. So yeah.
Wonderful. Thank you very much. Yes, I'm not surprised this Spoke came up. It's a popular spot amongst all of our student panels, but I'm glad you all mentioned there's you'll find your own unique place to study, and that might change whether it's a group project. You mentioned some areas are a little bit more collaborative than others, and if you just really want to focus in a quiet spot, you can find those places as well. So thank you. All right, penultimate question here. We may have some folks in the audience this evening that are making that transition from high school over to university. So we just like to know what advice might you give someone making that transition to Western for their first year? So we'll go in that same order. Shaunik, Megan, Lydia, and Lama can finish off.
Sure. So one good piece of advice, in my opinion, is that undergrad is not a short journey, and over that journey, you might make a couple mistakes. There might be a couple bad decisions or bad results, whether it's academic or otherwise. And one really important thing to know is that in the bigger context, it doesn't mean much. So try not to get hung over on a couple small things, and try to focus on those small victories and push yourself. And never think that one mistake or one bad result is going to stop you from achieving anything. And another thing I'd like to say is that in high school, you might not have given as much thought to what happens outside of class, but I feel like those extracurriculars that you have that Bryce mentioned, they're really important for avoiding burnout, especially if you're in an honor specialization program or you're taking a couple extra science electives or difficult electives. It's important to take care of yourself as well, whether it's by interacting with your friends and extracurriculars outside of the class. Just always make sure that you take care of yourself first.
Yeah, I think Shaunik made some great points about taking care of yourself with extracurriculars. Kind of on that same note, my biggest piece of advice would probably be to ask for help when you need it. There's so many different resources at Western, and it can seem like a really, really massive place when you're coming from high school, but it's made up of all these different small little communities. And within each community, there are people who are more than happy to help you. And if you find yourself asking for help from somebody who, you know, maybe isn't that helpful, there's somebody else on campus who can and will help you. And so it can seem like a lot of people have it together, and I promise you, not everybody does. Most people don't. And so my biggest piece of advice is definitely to ask for help.
Yeah, those are some great points just to add on. It's important to understand that it's okay to take your time. If, you know, at some point you feel that maybe you'd like to switch programs or kind of maneuver your courses in another field, that's okay. And Western is happy to help you do that.
I also encourage to put yourself out there and like get out of your comfort zone, because I know myself, I was very reliant on my parents. But ever since university, I kind of tried to become more independent, become an adult. And that really helped me actually like become more outgoing and doing things myself. having that initiative. So I do recommend trying to kind of take the reins of your life, basically.
That is some excellent advice. Thank you all for sharing that. I wish I would have had someone letting me know some of those things as I was making my transition, because it's easy to forget sometimes to think about those key points you brought up, but very, very important to do so. All right, and our last question, thank you again for your time, would be, what made you choose Western? So we'll switch up the order one last time. Maybe we'll have Megan start us off, Lydia, Lama, and Shaunik will have the last word there. So what made you choose Western?
So when I was in high school, I didn't really know what type of science I was going to like. I knew I liked science and I wanted a science degree, but I wasn't really sure where I wanted to take that. And I was also interested in some of the opportunities that a bigger school presents, while still being able to have that community feel. And so Western has a really strong campus spirit, a really strong campus community. And in addition to that, I really sought out Western for the integrated science program. The community feel is so strong there, and it's such a nice, small little program. You get to know everybody really well. There's a lot of different opportunities to try different things and to make different connections and try different research opportunities and internships. And so the supportive atmosphere, while accompanying the bigger school opportunities, I think was a really important thing for me. For example, I came into university really hating physics. And I thought that after I got it out of the way, that'd be it. But here I am 3-4 years later with a physics degree. So I think integrated science was a big one. And again, that small community within the bigger school and community as well.
Yeah, I was always, considering Western just throughout my years in high school, but it was definitely nice that it offered all 3 programs which I was looking into, which were science, medical sciences, and engineering. And I ended up sticking with science, obviously, but it also helps that, there's a nice, pretty campus, and especially when the nice weather is out, it's just a nice experience. And after visiting the open house myself, I knew my decision was made then.
So I've been moving countries all my life, basically, but I am originally from London, and I was applying to several different universities around the world. But I did come back to London, essentially, because it's the easiest move, as well as seeing that it's like at the top 20 for computer science programs in Canada. That's obviously very appealing. So I felt like University of Western Ontario was like the best choice for me, as well as I fell in love with campus, as Lydia said.
Yeah, so my reasons are very similar. I chose Western because of its reputation as a top-tier research university, as we previously discussed, especially because it has very high research output relative to the size of the university. And I also personally wanted that mixture of having the resources and the availability of a bigger university, while also having that smaller city community and atmosphere within campus. So those 2 factors, as someone else had previously mentioned, are combined into my choice of Western, as opposed to other programs in bigger cities like my home city of Toronto or Vancouver, Quebec, etc.
Wonderful, thank you. Well, no matter what your reasons for choosing Western were, we're very glad that you chose Western and you're here with us now, and some of you now moving on to master's programs and whatnot. So thank you so much for taking some time out of your schedules. I know finals finished up not too long ago, and some of you are busy working away with other school projects or internships. So thank you kindly for being here with us tonight and sharing your experiences. We really appreciate it. So have a great night, and thank you again. All right, for our attendees out there, we know that you've been asking some questions throughout the event tonight, and now we're going to set aside a little bit of time to answer some questions live. So if I can get our wonderful volunteers from the Faculty of Science back on screen now, we'll take a few questions and answer them live. I will jump into the Q&A box here and see if we can tackle some of these. So this is a good question actually for some of our student panelists. how many clubs do you think is a good balance, or how might you balance some of those extracurricular opportunities and then also, focusing on your academics? Do you have any tips or strategies for doing that?
I guess I can chime in here. So I would say that my personal experience and my advice would be to pick a couple of things that you want to invest your time in. So if you are in a lot of different things, then it can be difficult to manage all of that at the same time. But if you pick, I would say 2 to 3 kinds of things that you're really interested in, and that way you can get as much out of it as you can while still having a bit of variety. And then for those other things that maybe you didn't get to add in while you're still interested in, there's a lot of events and other open house nights and other ways to still include that without perhaps having it being another thing on your plate.
Wonderful. Thank you, Megan. Sorry, it looks like I'm seeing Shaunak and Lydia unmute. So Shaunak, if you want to go, and then Lydia can follow up.
Sure, I just wanted to echo that as well, because you don't want to spread yourself too thin, and you also don't want to take on more than you can chew and end up losing sleep or losing time for your academics, which should be a higher priority. And it also varies within each individual club or extracurricular, because you could be just a part of it, or you could be help running it in something like an executive position. So each different thing, you can have a different amount of workload associated with it. So based on that, you can decide whether I want to be a crucial member running things in 2 or 3 different things, or maybe I want to explore multiple things in first year and be a part of 4 or 5 different clubs as a member.
Yeah, I think especially adjusting to first year, it's important to, remember that it will be an adjustment academically, and just, again, not to spread yourself too thin, maybe stick to 1 or 2 clubs and then add on with the years.
Wonderful. Thank you very much. Yeah, I think that's important. You can kind of monitor your own involvement in those clubs, how involved you do want to be, whether as a member or an executive or something like that. So thank you. We've got another question here asking about some of the experiential learning opportunities, how something like co-op might differ from an internship in science. So I'll pose that to our student and staff volunteers.
Well, co-op is a requirement in many programs. So I think, it's well known Waterloo offers co-op. The challenge with that is that it's a requirement part of your degree requirement program. And the challenge is that every 4 months you're either at school or you're out on a placement. And so in that, do you actually in those 4 months acquire the tools and experiences that you would seek to disseminate that this is a company, 1, that I want to work for, or 2, is this a field of study or area of work that I want to do? And in all likelihood, that possibility exists. Where internships differentiates, and I think separates itself, is the fact, 1, it's not a requirement for your degree. You're not obligated. It's not a requirement. It's highly recommended. I think you would reap great rewards from it and benefits from it. And the other thing is that because it's an 8-month up to 16-month placement, you are now affording yourself the opportunity to really do a deep dive into the company. It's a great opportunity for you to vet the culture of the company. Is that something that lines up with your value system? Also, it gives the opportunity for the employer to do proper vetting and say, does John have the abilities and talents that we're seeking for? Hopefully, yes. And then often, as Dennis touched on, is that when on your last week, as you leave there and you hand back the office keys and so on, they're like, hey, John, when you're done your studies, a year later, we want to offer this position for you. So it's a great opportunity. It's a good yin and yang for you, shall we say, for you to disseminate from your point of view, if you like the company, and from their vantage, are you a good fit?
Wonderful. Thank you very much, John. And just a quick follow-up to that. If a student were to go out and maybe find their own company that is welcome to do an internship, is that something that they can set up, or are there kind of predetermined companies that are that you have to do an internship with at Western?
It's my understanding that so long as it's vetted, so there's certain requirements and arrangements that have to be established. So the individual would be wise to connect with the Science Careers Office and just have that, bring that conversation forward. There's some contracts that have to be signed. I do have to explain one thing to that internship. It is an expectation and actually a requirement of the program that you must return to finish off your studies for you. So what it does actually adds a fifth year to your studies. So you do 3 years of studies, as Dennis said earlier, you do a year of internship and you return. But yeah, there wouldn't be an issue with that. Hopefully it's approved. I can't say for certain if it would be approved, but I'm confident that there wouldn't be an issue if you were to do that.
If I can just to add on to that.
Go ahead.
I know a lot of students who sought internships at companies that perhaps were not already connected with Western, and the internship office has been very flexible and very able to make those work wherever possible. So I would say if there is a company that you're able to secure an internship at, there's a pretty high chance. I can't say anything for certain as a student especially, but I would say that generally students have had success when they find positions at companies that may not already be listed on the Western site.
Wonderful, thank you. Yes, those internship opportunities are so valuable. Like has been mentioned multiple times throughout the presentation, you get to build that relationship with maybe a potential employer in the future and get to really test out and see if you enjoy that field of work. So last question here. I know we touched on it multiple times. Research has come up a lot. But for a student, maybe in first year, they're just getting into Western and they're eager to get involved in research right away. How might a first year student do that? Would it be connecting with a professor? Is there a certain person they should talk to or place they should go if they really want to be involved in research right away?
So I guess I can answer that, Bryce. Yes, I think there's no better way than to reach out directly to a professor. So I think the demand, the number of students far exceeds the number of positions, the number of labs, in fact. But I think to write an effective email that says, I visited your web page, your website, and I'm really interested in the research you do in X and Y, because of what? Because this is the field I want to go into. Like that's an effective way to approach a professor, other than, hey, do you have a position in your lab? It may be just volunteer, but if you get your foot in the door and they like you, then it's very likely that you will stay on for years. But yeah, first year courses are big, but that's okay. Professors are very approachable. So after class, or fire an email, hey, can I chat with you during office hours about this? Yeah, direct email contact.
Wonderful, thank you very much, Dennis. And yeah, it sounds like research has played a big role in our student panelists' experiences at Western as well, and having that research experience in undergrad may also prepare you for postgraduate studies if you are interested. So that is all the time we have for tonight, folks. We'd like to thank you again for coming out, and a huge thank you to all of our faculty, staff, and student volunteers for making this event possible. We know it's a very busy time of year, but we greatly appreciate you adjusting your schedules to be here. And of course, thank you to all of our attendees. We appreciate you joining us this evening. We hope that you got all the information you need. If something comes to mind later on, feel free to connect with us. There are a number of different ways to connect at welcome.uwo.ca. You will also find a recording of this presentation posted there. We're going to hang around for just another minute or two, and we can type out some final answers in that Q&A box. But thank you to all of you for joining. Good luck on your journey to university, and good night, everybody.